Hello everyone, this is Sangeetha, Assistant Professor EC Department, SNS College of Engineering. So in the last video we discussed about the basic microprocessor and its working, and 8085 microprocessor and its architecture and the registers associated with the processor. So in this video we are going to see about the 8086 architecture. So 8086 microprocessor is a 16-bit microprocessor. So as I already said, 16-bit microprocessor means the data bus with is 16-bit and it can process and transfer 16-bit at a time. And it has 20-bit address line. So the address bus width determines the total memory capacity. It can be calculated using 2 power 20, that is 2 power 20 is 1 MB. So it can support up to 64 kilo input output ports, so that we can connect 64 input and output devices, external devices. So there are 14 registers. Each register is 16-bit wide, and it has a multiplexed address data bus, and 33% of duty cycle, that is the on period is 20. The on period is 20. The on period and off period, so that is the clock cycle. The clock cycle is generated by the oscillator, that is the clock pulse is generated by the oscillator, that is crystal oscillator, and the on period is 33%. It can prefetches up to 6 instruction bytes, and there are two modes of operation, minimum mode and maximum mode. In minimum mode we can connect only one processor, and in maximum mode we can connect more than one processor. So this is the basic details of 8086 architecture, and this is the architecture diagram of 8086, and there are two units. It is divided into two units. One is BIU and another one is EU. BIU means bus interface unit and EU is execution unit. So the bus interface unit is responsible for handling the external bus operation. That is, it manages data and address bus interfacing with external devices and memory. So it performs segmentation, addressing calculation, and generates memory addresses. Also, it is mainly used to fetch the instruction bytes from memory and feeds them to the execution unit for execution. Also, the bus interface unit handles instruction prefetch queue management, because the 8086 can store 6 bytes in a queue. So, and instruction queuing, it supports various types of memory addressing. And the execution unit is responsible for executing instruction fetched by the BIU. Also, it consists general purpose registers, ALU and flag registers. So ALU unit executes arithmetic and logical and control flow instructions, and EU also handles interrupt and exception processing. It also manages data movement between registers and memory. So the architecture is based on non-human architecture, which means that both data and instructions are stored in same memory and are accessed via a single bus. That is called non-human architecture. So it has a general purpose registers, that is AX, BX, DX, CX, and segment registers, CS, SS, DS, ES, to handle memory segmentation. So the 8086 operates with a clock speed ranging from 5 to 10 MHz, and the total memory capacity is 1 MB of memory. So overall, the 8086 architecture with its BIU and EU units laid the foundation for subsequent 80286, 386 processors, which have evolved over the years to become one of the most widely used processor architecture in personal computers and servers. So hope you all understand the architecture of 8086 and the functions of various registers, and the two units of BIU and EU. So overall, this is the register organization, and these are the segment registers. So these are the assessment question. Can anybody answer this question? Identify the operation arrows. Stack. So there are some registers that is called SPBP, that is stack pointer, base pointer, and DISI or index registers. So in the next video I'll explain the register organization detail. Hope you will understand the basics of 8086. Thank you.